First, I will introduce myself. My name is Mercedes Wyss. I am from Guatemala, and I am community leader to a JDuches chapter that are the female chapters of Java, and I have a Google community that is called Devs Plus 502. In the past, I was member too of Guatemala Java Users Group, and actually, I am a CTO in a startup called Productivity. I am Auth0 Technologies Ambassador and an Oracle Developer Champions. And so what we will talk, or what points we will take today, we'll start explaining what is serverless. Then we will talk about function as a services. We will see the serverless architecture, what benefits and drawbacks have this. And then I will show one use cases that is most user serverless. And I will show you a demo to create a serverless function with a web task. And finally, I will talk a little bit about the FM project. So let's begin. Serverless architecture has two definitions during the history that exists. And at the beginning was created about the backend as a services. But this was when we started to create mobile applications. So serverless start to begin like this solution for provide backend services to a rich client application. And in nowadays we know that as like function as a services, but the problem is that when we look in internet, we will show or find information related to the backend as a services. But in essence, serverless is anything when we don't manage our resource, basically the server side. So I will talk to you a little bit about the backend as a services. So this exists, like I was saying to you, when we were developing rich client applications, and we don't manage the server side. And I don't know if you know Firebase database or parse. Anyone know? No? Yes, someone, yes. What is the magic of the Firebase database? It's a database in real time that I don't need synchronize the information for the client to the database in the cloud. The database make anything by themselves. It's like dark magic behind. So this is the first definition of serverless. And then it was confused too with things like platform as a service. That is when I delegate what part of the development to a third platform. One of the most common here is delegate authentication part like Auth0 or Amazon Cognito or the Oracle Identity Cloud Services. The next thing, now we use services using function as a services. There are the state compute container part in serverless that are event triggered. And the function as a services are ephemeral too. What means this of ephemeral? I say that it's a cheap way to call that is dynamic, or we can work elasticity, right? And then it's fully managed by third party. That means that I will not take care about to manage the services. And some people believe that serverless means that don't exist services. But the truth is that don't exist the management by ourselves of the services. We delegate that part to a third-party person. And one of the most common technologies, or the first one that exists, was Amazon Lambdas. We have now the Google Cloud Functions, Firebase Function, Azure Function, and the FM project. Now, what are the key characteristics about serverless? Like I was saying, we don't have no servers management. That means that I don't need to create my servers, configure the servers for have my environment for run my applications, stay pending of the monitoring of my services that, well, was available. Will be a flexible scaling and high availability. That means that my functions always will be available in that I have a lot of high of concurrency trying to access to my functions. And the next part is that we only will pay when we are using our server functions. So what happened with this of I only pay I use? It's like I have a function, and since it's event triggered, only when someone calls my function, this function will active, and I will pay just for the seconds that is running, and the amount of memory to this function is using in that moment. This is a small resume. We will don't take care more about the server configurations. We will have a server or a backend that always will be available. I will be fast. It's fast because we, in serverless, for any request, we will create a function for attend this request. And finally, we will only pay for what we use. So what is not serverless? So serverless is not anymore a platform as a service or some service that provide me one part of my development. Are not containers too, and don't mean that we'll not make any more DevOps, because we equals need to take care about how we'll monitor our functions, or how I will catch the logs to all my functions, how I will manage my versioning to the functions that I am developing. And then we will talk about that in the future of this talk, but some people confuse that serverless are stored procedures as a services, because one of the most common cases of serverless is that we use them for detect changes in a database or in a storage. So people believe that that is serverless. So here are a little bit for see the difference between the three things. So the first one is that when we are using an infrastructure as a services for run our platform. So we need to take care of these services, and then there we will run our business app. If we are using a platform as a services, we have one part of our implementation in a services, another part we will use it with platform as a services. In serverless, we don't need to take care of anything of those ones, just programming the functions. So this is an example of a monolith or one microservices. Then I need to have a host instance and configure that one. And inside the host instance, I will have my application. And my application have all my operations. In serverless, I will have my function as a services platform, and I will take care only to develop any one operation there. So where is the function as a services? So function as a services is one part to serverless architecture. And this is something important to understand, because serverless, some people speak about function as a services in the same level to serverless, but it's not. Serverless is the architecture, and the function as a services as one part to all this architecture. Then are deploy an individual function, action, or piece of business logic. Some people call the function as a service nano-services. So I will take care only on one functionality to all my platform. And are event-driven, or this is of event-driven. So we will react or exist only when someone calls them, not like in the monoliths or microservices that I have an instance, and my application always is running in this instance, instead when anyone is calling that one. Then the principles of function as a services is that we can completely have an abstraction to all the rest of the things that happen in the way to that developer. So what means that? When we will develop an application, so say, okay, we need to decide which technology we will use, which app servers we will run that one. And when I will start to develop, I need to create a development environment. I need to configure Glassfish for can run my implementation. I need to say what IDE I will use, or if I will use just, I don't know, Sublime or Visual Code. So I need to define which database I will use. I need to configure all that for can run and test my application. When I am developer and I am using serverless, I only need to take care of the function as a services, create my code, and test that one. Then is the fact of the billing. I just will pay for when I am running my service. And finally, is the same thing, is that event-driven and instantaneously scalable. It's instantaneously scalable because I only, that I mentioned, I will have a function for attend any request. So if I have 1,000 requests, I will have 1,000 functions running at this same moment. The cloud sends towards serverless in terms of the function as a services. This is something a little bit complicated because we start to using this serverless, but they never tell to us the other part of serverless that we will need to configure an entire architecture. So they say, okay, don't worry, you can run your code easy. And in that, we will show that, but I don't need to create any environment. I just signing in the cloud and copy my code there, and it's running. So one of the things that we need to take in mind when we use serverless is the state of the functions, because are stateless. That means that don't save any state. So the function is created, run, and then death. And it's like that function never exists. So if I need to save a state, I need to create a strategy, like stay saving that state in a database or on storage. The next thing that we need to take in mind, and this depends on the cloud or the platform that I will use for run the function, is that we have some restrictions. So for example, AWS Lambdas have the restrictions that my functions cannot run for more than 5 minutes. So if I have a function and past 5 minutes and I didn't end my process, the function will dead, and they don't care that. Then we have restricted of programming languages. Many of the solutions that exist now restrict to us to use Node.js, for example. Java is only in 2 or 3 platforms, and that have a reason. They have something that is called the warning time. What means this warning time is that when they will create a function, they need to pass through this process to compile this code. So some programming language can run faster, but others not. And for that, they are restricting all these amounts to programming languages. For example, Azure functions have a lot of programming languages, but they say, okay, you need to choose, or we need to see what kind of strategies we will use for maintain warning your function, for don't need to pay an accident, always that we will warn before to run that function. And finally, many clouds restrict to you to put all the serverless architecture using only the technologies of the same cloud. We will talk about that when we see that diagram of the serverless architecture. So we will talk about the serverless architecture. So basically, we have this diagram. We have a user that uses a browser. So our browser is a client. Could be to a mobile application or an EOT project. So this one, we will connect or communicate with an API gateway. The API gateway will be the one on charge to manage all the endpoints. So the API gateway will say, okay, I have this endpoint, and will connect to the function that we want. And any function can connect to the same database or to other one. And this part of there are the function as a services. So this is a most complicated diagram. I will put myself here. So we have here, these don't have a light. Wait. This one. Okay. I don't know. Yes, okay. This is our client. One really common right now when we are using serverless or microservices is delegate other activities or functionalities to our application. And the most common one is delegate the identity management to a platform as a services. So what established the architecture is that my client will connect to the authentication services when my client needs to make login. So the client will connect to this one for make login. But we can have databases that don't require we make a login. For example, if I have a catalog of products, what I need to make to my client may login for show the products. He can watch the product without a login. So we will provide access to our client to access direct to this database for show our products, for example. Then we can have functions of services that don't need to pass for the API gateway. Then we will have the communication with the API gateways that we will manage all the endpoints for communicate with the functions. And here is an interesting part, because we need to verify before if our client have access to communicate with that functions. And usually when we are developing monoliths, for example, in the same function, I made the verification or the authorization process. In this diagram, the API gateway will make that part. And the API gateway will communicate with the authorization services. For say, well, the authorization services will return to our client a token. Typically now is just JSON Web Tokens. So he will send the JSON Web Token to the authorization services, and we say, okay, this guy wants to communicate with the calculate cost. So he has permission to consume the calculate cost, and he will return to the API gateway if he has permission or not. If he don't have permission, the API gateway will reply to the client and say, you don't have permission, and will specify why. So maybe it's because the session expired or he don't have permissions for that. If he has permissions for that, he will connect to the function that the client is requiring. For example, this function is not consuming any database or any file storage or pipelines. So this one consumes two things. So this is a more complex architecture. So this is something that is combining monolith microservices and serverless. And I am putting this one because I was giving this talk in other places, and one of the most common questions that people make me is, where is the difference between microservices and serverless? People just know that it's something new that we divide in something more small, our applications, but don't know the difference. So here is, we will, when we are switching between architectures, the complexity, not in development, if not in the DevOps, is more complex if I use microservices or serverless. But the part that I want to show here is that, for example, in the monolith, I have all the functionality or my application in one same place. With microservices are divided the functionalities. So in that, I can have any functionality, or this is better say a module of functionalities in different services. But when I am using serverless, I am talking about just one functionality. So I will show this next diagram. I have a monolith application, I divide to microservices, and I divide to functions. I will use the same example because I like to mock, but all of us use banking applications, right? For see how much money I have. You know, you are in a party and you say, I have more money for buy more beers, and you go to the app and check, right? Many ones are laughing because it's true, you made that before. Okay, so the banks have the part when I can manage my accounts. I can make transactions, you know, transfer money. And I can pay account, pay loans, pay credit cards, or pay services like water, electricity. So in one monolith situation, all these ones we will in the same bucket. If I divide that into microservices, I can create a microservices just for manage the account information. I will make other microservices for manage the transfers. And then I will make a microservices for manage the payments. If I make serverless, I will make functions for consume my checkings accounts. So which ones are my checkings accounts? Or what is the balance that I have in this account? Or I will make other function for me a transfer between my own accounts. This is basically the difference between the microservices and the serverless. Some ones call serverless, or at least the function as a services, and nano services. So we will continue about the benefits and the drawbacks that we have using serverless. So the benefits of that is that we will reduce the time when I can create something and put that in production. Since I don't need to stay creating any development environment or configuring services for that development part and the QA part and then the productions, I just put the code and it's running, so I have something. The next thing is that we will reduce the operational cost. This is not about the cost instead of infrastructure, if not is the cost of how I will pay to a developer. I don't know here, but I see that I make estimations in time of how hours we will use for implement something. So we always need to include these development configurations. So for make one function, maybe I will need to put 10 hours. But now I only will put 1 hour. So that means that I only need to pay to me 1 hour. And I will reduce this time when I am development. Then is the infrastructure cost reductions. Since I don't need to stay paying for have an instance running all the time, I will pay now just when my function is running. So this cost for pay the infrastructure, we will reduce it. So there's the other one are related with the other ones. And what are the drawbacks? This is interesting, the first one about the problems due to third-party API systems. This is the failure to lose the power or the control over the things. And I put the example to when Java came to the world. So all of us know where is a garbage collector, right? Yes, no, everybody moved the face. So ask to someone in university, you know where is a garbage collector? And say, what the fuck is that? Okay, and you say, okay, you know where is manage your memory when you are creating objects? Again, they say, where is that? Because now all programming language manage that. But when Java came to the world, that was the boom. So, you don't need to create any more destroyers and stay destroying your objects after using that, or lost all your memory in your computer because you forgot clean your memory. And the developer says, no, this is something bad because we will lose the power to manage the memory. And now it's the same thing. The people say we cannot lose the power to control our servers. So for that is a drawback, but it's more a fear. The next thing is that we have architecture complexity, and that is related with the other things. We have a lack in operational tools. We need to monitor our functions. And the sadly part is that I was investigating, but don't exist many tools for main monitoring of the functions. And all the ones that I found investigating are only for monitor AWS Lambdas. So we have this problem. Or how I will manage the logs to all functions. How I will catch that in one tool. Since the function as a services are managed for one cloud, I cannot use something outside for manage logs there. So this is something really negative. Or how I will use make for manage versioning. I will versioning every single function, or how I will make for versioning all the project with all the functions together. So these are things that we need to sit and think about that. So in which cases we can use serverless, or are the most typical used? So here is one example when the people is divided this pet store server for manage with functions. So the truth is that sometimes we in our system have one functionalities that are more user to the other ones. So maybe for that it's better delegate these functions to a serverless architecture. So they have a client. The client use the pet store server, and the pet store server is communicated with the database. So they are migrating that to a serverless. So for example, Amazon have this new Amazon Dynamo database that is precisely for make these things. Provide to the client the capacity to connect directly to a database for obtaining information that don't require any kind of filter. So the client, we will consume to the authentication service, and I will connect to the API gateway if I need to purchase. So for example, I want purchase. For purchase, I need to, my client is previously login, and I will make the purchase, and I will have a database for purchase. Here, we have two databases, because this is the one that everybody can access without making a login, and this is the other one. And we have here a CR functions that we will connect to that one for kind of return to the client the results. So this is other example. This is for AdWords. The AdWords is these announcements that we saw. I don't know if here happened when we enter to a newspaper to read the things. And some newspapers have a lot of AdWords that we don't know which is part to the news and which is an AdWords. And I think this is on purpose where we can make click there by accident, and they can obtain a payment for that. But what happened with the AdWords? So when I configure an AdWords in any platform, for example, if I made Facebook announcements, publicity. So I say, I want you put this publicity during 3 days, and I will provide to you $3 per day. And imagine that every click have a cost of 5 cents of dollar. So when I make click in an AdWords, I need came to a click processors, and the page say, okay, database, we need to erase $5 to the $3 that this guy have. And I will reduce, to $2.95 to $90. And when I don't have more money, they will don't publish anymore this publicity during that day. So, but how many AdWords manage one platform? Imagine that. So they suggested to send that to a serverless architecture. So I will make click, and I will create a function for manage this click to this AdWord. I will continue. The next thing is data processing. This is the most common usage of serverless. So I put here an image. So when I don't know if you have experience making mobile applications. Anyone? Okay, don't worry. Oh yes, one guy. Yes, yeah, I don't know if, yeah. Okay, what happened with the Android cell phones, for example? We have cell phones that have a low resource and cell phones that have high resource. So how many of you have a cell phone with 1 gigabyte of RAM or more? Almost all of us, right? But exist people that don't, that have 512 megabytes or 256 megabytes. Yes, or have small cell phones that are LD, well, I cannot spell that in English, but have a low resolution in the screen. So what happened with the image? Imagine that I send this image that was taken with a high, powerful camera. So can be so heavy, can have 12 megabytes of size, and really biggest. If I put that in a low resource cell phone, I will have an out of memory error, because that cell phone don't have the capacity to put in memory this image. Or we'll have a outbounding because it's so biggest for the small screen. So what makes someone is that they use an storage like S3 in Amazon. And I came and I saved the image in the S3. And I have a function that will detect that I have a new image in the S3. And I will take that image and I will process the image for run an algorithm for reduce the size but not lose the quality. I will reduce the size and I will create sizes for any kind of resolution that have the cell phones, Androids and iPhones, or in that websites. So then when my cell phone says, I want to show this image, and my server will say, okay, what are your capacities? And I will return to that cell phone an image acquired to that resource. The other thing is detect changes in a database. So for example, I will return to the example with the Firebase database that is really common right now for can make mobile applications that work offline. So the cell phone, we will communicate with the Firebase database. And the Firebase database, we will have the information that are providing to me the cell phone. But the truth is that this Firebase database is not the final destination to all that information. But I need to translate that information to a database or a data warehouse when I want to save that information. So I will run a serverless that I will detect changes in this Firebase database for send that information to the final destination. This is entering data processing and are the most typical case in serverless. The next thing is the Internet of Things. I don't know how many of you are familiar with Internet of Things. Not much ones, but it's really simple. It's connect anything to the Internet and collect information to that. And basically, right now, it's working much for make things of marketing or study human behavior. But I have another example. How many of you have fishes as pets or know someone that had fishes? No, you don't have fishes as pets. Okay, but you see that we need to put bubbles inside the, I don't know how to say this, container when we put the fishes. They make blah, 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 blah. Yes, you saw that? Yes, yes. You are not so convinced. Okay, you know why? No, too, no, okay. The fishes need oxygen too. So when the water is not moved, this oxygen over and the fishes can die. And for that, we need that. Blah, 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 blah. The fact is that you have that in your bedroom is really bad for sleep. It's like, fuck this shit, fuck away. So, but the fishes you don't need to have that turning on all the time, just when the oxygen came down. So I can create a project that is collecting the how many oxygen is that 80%, 90%, 25%, and then I can send that to the cloud and make analysis over that. And I say, okay, if you go to sleep from 8 to 10, that is a lie with us like developers, but if you go to sleep to 8 to 10 and don't want to turn on this thing that make the bubbles, you need to turn on that at certain time. This is, for example, an example of an IoT project. So how many services I need to send the information of the monitoring of the water? Just one, right? So if I only need one server, what I will mount in a hosting instance, and I stay running that all the time, I don't need that. So it's used serverless, because I only need one function. The next thing is for chatbots too. The chatbot just receives what I am saying, and he will reply me something. It's not so simple like that, but we only need one server, one function too. So the next thing, I like this, the Frankenstein, because when we are talking about serverless or some new architecture or something new, like when came the NoSQL databases, is that I don't need to migrate all my entire system to using this new technology. We can have something that I call a Frankenstein architecture. So I can migrate only one part of all my platform to serverless. And I will put my example. So I have a mobile application, and we have a backend with 5 services. But of that 5 services, just one is consuming all the time, at least every 1 hour from any cell phone, and can be consuming more times. But this is only in office hours, from 8 a.m. to 5 p.m., from Monday to Friday. So we are having every time more cell phones. So that means that I need to increase the capacity of my server just for one functionality in all my platform. So for me right now, maybe it's better migrate this only function to a serverless for be available and have scalability instantaneously, and I only will pay for that in office hours from Monday to Friday, and continue having the other functions in a small instance. So for me, that is Frankenstein. So you don't need to implement everything in serverless. You can have something using microservices and something using serverless, or have a small monolith, another thing in serverless. So I will show you small demos right now. We will use WebTask. Is a functions platform that exists in the cloud. Something interesting with the WebTask, and this is why I am using that, you can use that free, and don't put your credit card for my test. And you can run your application there if you don't have so you only can attend one request per second. So if you want to make a prototype of an application of something, WebTask could be a good solution. And I will use MySQL in the Oracle Cloud. So I will show you right now some videos. The first one is for create my database in the Oracle Cloud. So this is how looks the Oracle Cloud. If you didn't saw that, I choose that MySQL. I have previously one database created, but we will choose create a database. And we will put here, I think that this is not reading properly, but I am selecting my instance name. I will put that description, and I put this is a demo database. Then you have a notification email. This is interesting because we don't need to stay waiting or making refresh for now to my instance is ready. They will send me an email. Now I will choose the capabilities that we have, CPUs and RAM, my database. I need to create a SSH publicly. So in this case, I can choose one existing or create a new one, like in my case. I will put enter, and he will create one, and I just will download that one and save in a really safe place, like my desktop, or some place that you can find that one. This is a demo, don't do that. I hate that people that say everything in the desktop. I don't know how they found things there. So the next thing is we can use high performance storage. I will say that not. I will choose, say how many storage I need for my database, from 100 to, I think is that 3,000 something. Then we have where is our admin user. So usually typical at the root, I put an admin user and our ultra safe password for anyone can hacking us. The next thing is choose, I don't know. Oh yes, the database schema name, and what will be our encoding in the database, and that time zone to my database. I put the time zone to my country, Guatemala, and the port that usually is 3306. And now I want to monitoring of my database, and I will say that I don't want backups because it's just for my demos. And finally, we will verify if the information is correct, and you will give create. I will say no because I have previously one database created. And then the most important part is that we need to manage our access rules. So I need to say what public IPs I will give. And I will say something when I was experimenting with function as a services, and it's for maybe why the clouds restrict to us only use things inside the cloud. And it's because when this is so dynamic, we will not have a public IP permanent all the time. So how I will say to my database, you know, maybe it will be these IPs, but maybe not. But the cloud itself can manage the permission. So I am creating this new function so I can go to the database and say just give permission to this new function to access to the database. That is something that we cannot do if I have things in one cloud and other things in other cloud. So right now I will go to web task and I will show how create. I have this in this database. I have a table that is called recipes, and I just put the name of some food. So I will show you how get the recipes that I have in this database. So I went to get task, I put create a new one, I put get recipes, and the first thing I will show is creating a function with a context and a callback. I will change the name of that for now. That is the callback. And the first thing is I need to the module for can access MySQL. So I create a var of MySQL. This is Node.js, and I say I will require MySQL. The next thing is that I will add the module MySQL to my function. So I will look to MySQL here, and I will add that module for can consume MySQL. The next thing is that we need to create the terms of the connection. So I will create a var connection to MySQL, create connection, and I will define where is my host, my user, my password, and the database name. So here, for we cannot put that as plain text, provide to us some secrets. So I will use in the context, and in the context I can access to those secrets for have the host, the username, the password, and the database name. So I will wait. When this finish, we will create the secrets here, because need to stay storage in some part. Okay, there is. I will go to the secrets, and I will add the secrets. So I have that host, and I put in the host of my database. Now, the next thing, you never do that. This is a demo, so please don't do that. I am using the root user. So, for example, in this example, I am just getting the information to the recipes table. So I can go to the database and create a specific user that only have read access to this table. So I have the secrets, and I will be continue, and the only thing that I need to do is connect to the database. And now I will eject the query for obtain the recipes. So I will create connection.query, and I will create a select from recipes. And I will put an order by my recipes ID, and I will limit that to only get to me 100. And finally, I will send here the callback. And in the callback, will return to me, to the client that is consuming this function, JSON with all the recipes there. And I will test inside the web task this function. So everything is working. We can solder the recipes that is in the database. And now we will go to the database for see that really is there that information. So there is the information of the database. So I will select the serverless. And there is. So right now I will use, if you see here at the end, we have an endpoint created with the web task, and I consume this function through this endpoint. I will use here is Insomnia, is a tool for can consume web services. I will put this one, and if it's done any fail, it's not demo. And there is the result. So you see, it's really simple. This video have a duration of 3 minutes. So in 3 minutes, I create the function for get information in a database, and I test that that function is working. Right now, I will show you other one. I will copy the other things, and now is for write a new recipe. So the first thing that I need is catch the JSON with the recipe that I want to add. One thing that I do here, I did here, is that this JSON came with the structure that I need for send that information direct to the database for don't need to parse the JSON. Then I am changing the query, putting insert into recipe set. And if you see, this is something that I put. I am not making a concatenation of my query, because there is when someone put to us, I don't know how to say goal, but SQL injection. So this is the strategy for don't have that problems. And finally, I am using the callback just for return me other new JSON with a response key, and I will put the same JSON that I sent to the function just for see that I received the correct information. Now I will use again the endpoint for can add a new thing. And I will go first to the database for see that you see that is not this new recipe before. So continue in the same state. Now I will go to Insomnia, and I will create a new function. Something interesting is that web task, if I will send a JSON to the function, they restrict to me that I only can access to post, not to get. So for anyone can watch the JSON when it's traveling. So I copy, and I will create the JSON. If you see, recipe name is the number of the file in my table. I put here a error. I didn't saw that. So add nothing to the database. So you see I put a semicolon, not a 2 dots. And now will work. So there is the response. And now we will return to the database. If you see, I have there a numus. So again, 2-3 minutes for create a function that will be add things in a database. So it's really faster. So we don't have much time, so I will talk a little bit about the FM project. The FM project is a new serverless solution that have Oracle, or is really related with the Java environment. And one interesting thing with the FM project is that it's multi-cloud, because don't restrict to us use any cloud. And this is because it's container native. So this is one. Maybe they are broken the definition of serverless, because I need to have a container instance for can run my FM projects. But the development experience can be better. So what problem did you see with the other functions? What happened is I have a really complex process. I need to put all the code in the same function. So I can have a function with 1,000 lines of code or 10,000. And I cannot divide my code in, I will have these objects in one file or these things in other ones. No, everything can need to have in the same place. And the FM project is improving this development experience. Then they say that are have vision and deep, because first you can choose many language for can make the programming, are not restricted just for one programming language, and it's open source. So it's based in 4 things. They have the FN server. I don't know if you use or know Play framework from Lightbane. Someone know? One of the cool things that have Play framework is that I don't need to configure any server application. I just need to install the Play, make Play run, and that will run magically. So they are doing that with the FN server. They work with Kubernetes and have the FN load balancer. That is that one that provides to our function a scale inside the container for have availability. And then have the FN FDKs. There are small development kits with different programming language. And finally, they manage the FN flow that is for managed orchestration. Orchestration is when I need to the functions communicate between them. For example, I will return to the example of the bank. When I will make a transfer between accounts, the bank need to verify if the account have money, for can quit the money to that account and pass to the other account. So the transfer function need to go to the balance function and say, you know, balance function, this account had money, and the balance function will say yes or no, and they will decide if may or not the transaction. This is orchestration. And this is a small demo, but I think that you will see, oh yes, you see. First, you can install the FM project. We have the FM project installed. You will start that. That will start the server. And now you can create the first one, and they are creating a directory called hello. And now they will create a hello function in Go, Golang. There is a programming language. So this is the function. This is a template function. So they are making an init in the FM project. So if you see, we have 2 ones, the fungo and the funjam. The jam file have information about the function. And then they are creating the environment of the Docker. And now we will run locally the function. So they are packaging the function for be compatible with Docker. And they will deploy. And now we will have a root in the Docker, so they will be verify the roots in my app. So this is the root. We can call locally using the hello, or we can have a endpoint too. So first are calling locally just with the path, and now we will use the endpoint for consume the function. And there is. So it's a little bit simple too, but here we need to configure an environment, a development environment, but we can choose different ones. So I will post this presentation in this GitHub. You will find a directory that is called Java Day Istanbul. And this is my fan page and my Twitter. I will put there too that the presentation slides and the video demos are uploaded there. And thank you for coming.